Alcohol use disorder is the most common form of addiction. Whether we've seen it on TV or actually lived it, I'm sure we're all pretty familiar with the effects that this disorder can have. But just to put it in perspective a little bit, the World Health Organization estimates that alcohol consumption is responsible for nearly 6% of all deaths worldwide. And in the US alone, 93 million adults, which is approximately a third of us, have or will meet criteria for an alcohol use disorder at some point in our lives. Today, I'm going to be talking about the relationship between alcohol use and inflammation. These are thought to kind of feed into each other, so humans and animals that drink more have much higher levels of inflammation in their brain and body compared to their more lighter drinking counterparts. And the reverse has been seen in animals as well. If you artificially increase inflammation in a mouse model, it makes the mouse want to drink more alcohol. But this hasn't been seen in humans yet, and that's where this experiment comes in. I'm going to be giving a group of heavy drinkers a low dose of endotoxin, a bacteria derived from E. coli, to artificially induce inflammation. And the effects you might see with this endotoxin are kind of similar to what you might get with a mild cold or flu, so a headache, nausea, or fever, and this is all part of the body's natural immune response. I know, kind of mad science, right? But the great thing about using this method is that it's a low dose, so it's very safe, it's controlled, and the effects wash out of the body within about 4 hours. So we can effectively induce this temporary, low-grade immune response and look at its effects on behavior in half of our participants who get the endotoxin versus the other half who get placebo. So what does endotoxin actually do in people with alcohol use disorder? I'm interested in their response to alcohol cues, and this can be measured in 2 ways. Behaviorally, I'll have them hold, interact with, and smell a glass of their favorite alcoholic beverage, as well as a glass of water as a controlled comparison, and they'll rate their alcohol craving on a series of questionnaires. Biologically, I'm also interested in their neural response. While they're in an MRI scanner, I'll show them images of alcoholic and non-alcoholic beverages and look at their brain activation in regions that are related to reward processing. The hypothesis here is that people who receive endotoxin will crave alcohol more and will have greater reward circuit activation compared to those that get placebo. And we also think this will correlate with levels of immune biomarkers in the blood. So when they're at their highest level of inflammation, we expect them to feel the worst and crave alcohol the most. Overall, the goal with this study is to shed some light on the specific role that inflammation plays in alcohol use. Despite how prevalent this disorder is, it's still severely undertreated. So it's my hope that eventually results from this study will help us develop new medications targeting the immune system to help people recover from alcohol addiction. Thank you.